Fusion Mobile, quality e-learning experience on the go.
Welcome to Fusion Mobile e-learning clinic. My name is Sonia Olaoluwa and I'll be walking you through the physics course. Let's take a quick look at the electromagnetic waves. In this topic, we'll just consider two things: the nature of the electromagnetic waves and the types of electromagnetic waves. What are electromagnetic waves? Electromagnetic waves are waves that are transmitted and they are produced and transmitted via electromagnetic fields or induction. Well, there are a lot of waves that fall into this range, and they all have certain things that are common to them all. One of the things that is common to all of them is that they all travel at the same speed, which is the speed of light. The speed of light is given as 3 × 10⁸ meters per second. That's the speed at which the light from the sun reaches us here on the earth. Some of the nature of the waves, all the waves share the same speed, but they are all on different wavelengths and as such have different frequencies. When a particular wave should have a high wavelength, it means it will have a low frequency, and when it has a low wavelength, it means it will have a high frequency. Let us look at the nature of these waves. A diagram is on your screen right now, and it is showing the different spectrums and this different spectrum indicating the wavelength and frequencies at which electromagnetic waves are being transmitted. We have the radio, that's the radio waves, which have wavelengths of about 10⁻³ meters to 1000 meters, and the infrared waves find their location within with an average of 10⁻⁻6 meters. The visible spectrum, which is known as the light waves, of course that's what we can see, is between the rays of 7 × 10⁻⁷ and 4 × 10⁻⁷ meters for red rays and all the. And when we have the ultraviolet rays fall within the 10⁻⁻8. The X-rays fall within the 10⁻⁻10 meters, while the gamma rays, which are the shortest, fall within the 10⁻11 meters. To calculate the frequency of operation of these waves, we can simply use the formula. Velocity of the wave is always equal to frequency multiplied by the wavelength, where v is velocity, and velocity, of course, is velocity of light, which is oftentimes described with a c, actually. So the velocity is equal to the frequency multiplied by the wavelength. So to get the frequency, all we just need to do is divide the velocity of light by the wavelength, which has been calculated. Which has been given. I haven't talked about the nature of electromagnetic waves. Some questions will pop up on your screen to test your understanding of and recurrence, ability to recall. Okay. I haven't talked about the nature of electromagnetic waves. Some questions will be presented to you on. I haven't thought about the nature of electromagnetic waves. Some questions will pop up on your screen to test your knowledge of the nature of electromagnetic waves. Welcome back. Well, we talked about the electromagnetic waves earlier, and now we want to look at the types. We want to consider them one after the other. Well, what are their uses, and where do we find them? How are they generated? What source do they come out from? For each of them, a particular diagram would pop up on your screen. The radio waves is very common to radio stations, and they travel very far distances. They can go as far, very many kilometers, carrying radio signals. That is one of the reasons why they are able to use them as communication systems. The shortest of radio waves is known as the microwave. The microwave is used in the radar system that is for monitoring location, monitoring system for aircrafts and ships, and also is also used for heating objects because of the nature of the wave. It is what is generated by your microwave oven. The next in line is the infrared rays. The infrared rays can go less distance than the radio waves can go, but they have a shorter wavelength. Infrared waves, they are found just beyond the end of the red visible spectrum. They have the chance of eating bodies without glowing. Bodies that a body that is, when a body is heated up, especially metals, when they are heated up to certain temperatures as high as 500 degrees C, that's 500 degrees Celsius. If it is below 500 degrees Celsius, they only emit red light. But when it gets to about 500 degrees Celsius and above, you start seeing them with a glowing red light. That is infrared ray at work. They start emitting infrared rays. These rays have a wavelength of around 10 raised to power minus 6 meters, and they have rays of around 10 raised to power minus 6 meters. Infrared rays can be dictated by their heat sensation. They are very, very useful in photography, that is in the development of films, that is from your camera and pictures. The visible light spectrum. The visible light spectrum, that's our visible light ray. That's the range in which our eyes can see. Those are the waves we can see with our two eyes. Now, it is labeled, it's made up of 7 colors, which are the colors of the so-called colors of the rainbow. It contains the red, the orange, the yellow, the green, the blue, the indigo, and the violet rays. These colors, they are the longest of all the rays of the visible spectrum rays is the red ray, while the shortest is the violet ray. The longest, which is the red, has a wavelength of about 700 nanometer. That's 7 times 10 raised to the power of minus 7 meters, while the shortest has a ray of about 450 nanometers, which is 4.5 times 10 raised to the power minus 7 meters. Ultraviolet rays. Ultraviolet rays are just beyond the violet ray. That is, after the violet rays, the next one you come to are the ultraviolet rays. They are emitted at about, they have a wavelength of about 10 raised to the power minus 8 meters, and they are produced by quartz mercury filaments or the sun. Yes, ultraviolet rays is produced majorly from the sun. That's how we receive them. That's how it comes towards us. They cannot pass through smoky glass or through the plane. They cannot pass through smoky atmosphere. That is, they cannot penetrate smoky atmosphere, and they cannot pass through glass, whether tinted or untinted, whether glazed or not glazed. But they have the capability of burning the human skin. It is what is responsible for the infection usually described as sunburn. Is sunburn an infection? It is responsible. It's what causes the sunburn. It's what is responsible for the phenomenon of sunburn. X-rays. We have all taken X-rays at one point or the other, and if not, we'll take it at one point or the other. X-rays they have wavelengths of about 10 raised to the power minus 10 meters, and they are fast moving. They're produced from fast moving electrons that strike metallic targets, specific metallic targets, which reduce their velocities. Now, X-rays are used in hospitals to destroy some cells, especially cancerous cancerous cells. They are also used for taking pictures of internal organs of the human body. X-rays can be harmful to people. Therefore, it's the amount of exposure, the level of exposure that one's level of exposure to X-rays should be limited, either in the industry or in the hospitals. Gamma rays. Gamma rays are very similar to the X-rays, and they have wavelengths of about 10 raised power minus 11 meters. They are emitted by radioactive substances and can be detected by the Gigamuller tube. Like X-rays, gamma rays also ionize and darken photographic plates. That is, they can also be used for identical jobs as that. They cause efflorescence, and because of they are used for similar jobs as X-rays. They can be used for cutting off tumors. Usually that is done in the medical line. Those are the types of electromagnetic waves and their uses, how they are generated. We talked in this lesson about electromagnetic waves, their nature and their types. We mentioned we listed them that by nature they all have the same velocity, which is the velocity of light. That is 3 times 10 raised power of 8 meters per second, and they all have different wavelengths. Because of this, they have different wavelengths, they have different frequencies. The longer the wavelength, the shorter the frequency. The largest of them all is radio waves, which have wavelengths of about 10 raised power 3 meters to 10 raised power minus 3 meters. And the shortest of the radio waves is known as the microwaves. The microwaves are used for radar systems and in our microwave ovens. Also, we talked about the infrared rays, that these are encountered just before the red light region. They are up to about 10 raised power minus 6 meters in terms of their wavelengths, and they are used for developing of pictures in the laboratory from our films. We talked about the visible spectrum. In the visible spectrum, we have the wavelength between 7 times 10 raised power minus 7 to 4 times 10 raised power minus 7. And that 7 times 10 raised power minus 7, that is our red light, and 4.5 rather times 10 raised power minus 7, that is that's a violet light. This is within our normal eyesight, what we can see with our eyes. Also, we talked about the ultraviolet lights. We said ultraviolet waves. We said that the ultraviolet waves are just after the violet, and they have wavelengths of about 10 raised power minus 8. We talked about the X-rays. We said X-rays have wavelengths of about 10 raised power minus 10, and gamma rays with 10 raised power minus 11. X-rays and gamma rays have medical use, such as cutting off of tumors or harmful objects, destruction of cancerous cells in the body. X-rays are also used for taking pictures of internal organs of the human body. Exposure to these things might be harmful, so the level of exposure is always limited. Having spoken of all these things, some questions will pop up on your screen in a few seconds. Please answer them, and if there is any part of the lesson which you do not understand, you can view the video one more time.